Alright, howdy folks. Here's question 1028. We first have to find the compressive stress, and that's in the column. So stress is basically like pressure. And there's our symbol theta for stress. So yeah, think of that as pressure, which is force per area. And here's what might trip you up. You'd think force would be F as the variable, but here it's P, so we'll see P meaning stress a lot, not pressure. So that P over A is meaning force over area. And the force that we need to know here is the force of whatever the column is supporting and the force applied from the column itself. And that number is given as 9 kip, or 9,000 pounds. Now we need to know the cross-sectional area of the column, the area over which that force is applied. So that would be this circular area at the bottom there. And that's also given as 120 square inches. So this has turned out to be pretty simple. It's 9 over 120. So 0.075 thousand pounds per square inch. If we want to take away the thousand, convert to just pounds per square inch, or PSI, that is to say, we can just move the decimal point 3 places. And that's pounds per square inch. Our next task is to find the bearing stress. This is the force on the ground underneath this whole footing here. So in this case, the area would be the whole square area underneath this big footing. So the side we're not seeing is back here, and then like that. So this area we're looking at is of this square. And also, well, that's it for the area, but what we have to think about in terms of the force applied is we have all the same force from the column, so we have that 9 kip, but then we also have force from the weight of this whole footing itself. That concrete can get pretty heavy. So here's what our math might look like. We got bearing stress equals the force per area. Here the force is the 9 kip from the column plus the weight of the footing. And the area over which that is applied on the ground is over a square, which is 25 inches on each side. So first we have to figure out the weight of the footing. We can do that using its density and volume. We know that density is mass, or let's say weight, over volume. So mass is density times volume. We're given the density of the concrete. It's 150 pounds per cubic foot. Cubic feet is the volume. Remember, you can take any length and cube it and you get a volume. So we need to find the volume here. So let's see, width by depth by height is the volume. So we got our width and our depth, 25 inches, and our height was 6 inches. But since we were given the density in cubic feet, we need to convert these to feet. So I'm just going to divide the inches by 12 to get feet for each one. And that gives us this kind of math. We cancel the cubic feet. And we find that our concrete footing weighs 325 pounds. So we need to add that to the force that the column is supporting. Remember, this is where we were. The force here is the 9 kip plus that 325 we just found. 9 kip is 9,000 pounds. And 25 times 25, that's the area, is 625. And that's square inches. And did a little math. And we get our final answer, 14.9 pounds per square inch.